Hi, this is Mrs. Baston. Today we're going to talk about many electron atoms, which is section 6.7. So when we look at the electron configuration of an atom that only has one electron, we notice, if you can notice from this diagram here, that there are a lot of orbitals at the same energy level that have the same amount of energy. So if you look at like the 2p, the 3p, the 3d, because there's different configurations of those, different orientations of those, you see those 3 boxes together and those 5 boxes together. Those correspond to the 3 orientations and the 5 orientations. For this particular diagram, when there's only one electron, those are all on the same level. And what we call those is they all have the same energy, and we call those degenerate orbitals because they all have the same amount of energy. And when you look at this next diagram, once you start adding more than just one electron, because the electrons are negatively charged, they start repelling each other, which pushes a lot of these things to different levels. So if you notice now, the 2p orbitals are still degenerate at one level, but the 3d has been kind of pushed out of the way. So this time, now that you have more than one electron there, orbitals on the same energy level are no longer degenerate, or they don't have the same amount of energy. The other thing that they noticed that in the 20s was that if you have 2 electrons in the same orbital, they don't have exactly the same energy. So what they used to describe that is they described their spin. So that means that the spin of an electron describes its magnetic field, which affects its energy. So what they came up with is that they are assuming that these electrons spin on an internal axis in opposite directions. So if you have 2 electrons in the same orbital, in the same orbital box like you saw on that previous page, because like we said before, each orientation holds 2 electrons. So if you have 2 of them in the same orbital, then they have to have opposite spins. So this led to a 4th quantum number. So we talked about the 3 quantum numbers the other day. Now this is a 4th one, m sub s, and this stands for the spin quantum number. There's only 2 values for this, plus 1/2 and minus 1/2. Again, these are arbitrary designations. So you could call the plus 1/2 the one that has the up arrow, the negative 1/2 the one that has the down arrow. But for them to be in the same orbital, they have to have opposite spins. So this is called the Pauli exclusion principle. So no electrons in the same atom can have exactly the same energy. So that means no 2 electrons can have the identical set of quantum numbers, or no 2 electrons can have the same address. So again, we talked about before how they can have, lots of electrons can have the same n value, they can have the same L value. You can even have 2 electrons with the same m sub L value. But when you get to the m sub s, that 4th quantum number that we're adding on, they have to have different numbers. They have to have the different spins.